Okay, so I'm going to try to get into one inversion and one differential equation in this video. So these are examples from 6.3 and 6.4. And so first up is this inversion problem where we have this exponential function times s plus 1 over 2s squared plus s plus 2. And the main thing I wanted you to get out of this is that we want to think about this as e to the minus 5s minus e to the minus 20s times h of s, right? Because if we think about it that way, then the inverse Laplace transform is just going to be u sub 5 of t times h of t minus 5 minus u sub 20 of t times h of t minus 20. Okay, so this big mess here just reduces to really just inverting the h of s. Okay, so let's go ahead and do that. So our h of s is equal to 1 over, or s plus 1 over, let's see if I can get my thing to draw here, over 2s squared plus s plus 2. And really this is more a problem of algebra than anything else. This denominator here is going to be irreducible, so I'm going to go ahead and factor out the 2s squared plus 1 half s plus 1. That'll just make things a little bit easier. Then I've got a 1 half s plus 1, and now I'm going to complete the square in the denominator. So half of the middle term is 1/4, squared is 1/16, and then I'll have 15/16 left over to make up for the 1 there. Good. And now I can rewrite this as 1 over 2 s plus 1 divided by s plus 1/4 squared plus 15/16. Good. Now I don't want a 1 here in this position. I need a 1/4 to match this bottom, and so therefore I'm going to rewrite that. So I'm going to take the 1 half there, and now I'm going to have s plus 1/4 to match my denominator. Okay, which leaves 3/4, right? So I'm going to go ahead and put the 3/4 with the second fraction, and then I'll have a 1 over s plus 1/4 squared plus 15/16. But I don't want a 1 in this position. What I want, maybe I'll use a different color. What I want is the square root of 15 over 4, right? And so if I want that to appear there, I'll go ahead and multiply by 4. Oh, this is too thick. Is red better? Square root of 15, well, not much. Okay, okay. You see what I'm doing? Multiplying and dividing by the same number here. Okay. And so going back to our normal thing here, so then I'll have 1 half. I'm going to go ahead and feed through the 1 half, and then I'm pretty much done at this point because I have the exact form that I need for my table. And then let's see, the 4's cancel here, so that's going to be 3 over 2 square roots of 15. Square root of 15 over 4. Okay. Okay, so I think we are ready. Now, h of t is therefore 1 half e to the minus t over 4 cosine of the square root of 15 over 4 times t plus 3 over 2 square roots of 15 e to the minus t over 4 sine of the square root of 15 over 4 times t. And there we go. There is our solution. And actually the solution overall, remember, let's scroll back up. was right here, right? And so I'm just going to leave it kind of in a shortcut that way, right? So, all right, and I'll allow you to do that as well. Okay, so now let's try to do one more example in our 10 minutes here, and let's see if we can solve a differential equation. And the differential equation I want to solve, let's see if I can find it. For some reason I don't have it in front of me. There we go. Y double prime plus 3y prime plus 2y is equal to f of t, where f of t is 0 up until time 2, and then at time 4 it's up here at 3. Whoop. And so the function looks like this. Okay. Now, when we're trying to solve this, probably the first, I'm also going to have 0 initial conditions, which will make my Laplace transform a little bit easier. Now I want to find an expression for this using the heavy side. And so really the only thing that we're turning on here is this function between times 2 and 4, and then it's the constant 3 afterwards. So let's see if we can find the equation of this line segment here. The slope looks like it's 3/2, and then if it goes through a point like 2, 0, we could write y minus 0, right, is equal to 3/2 times t minus 2. And so what do we get? Y is equal to 3/2 t minus 3. Okay, so f of t then is going to be this line turned on from u2 to u4. So let's go ahead and write that. F of t is equal to u sub 2 minus u sub 4 times our 3/2 t minus 3 plus 3 times u sub 4. Okay. Good. Now we just need to write this in terms of the table. When I'm using a table, I like to put everything that has to do with u sub 2 together, and then everything that has to do with u sub 4 together. So this will be 3/2 t minus 3 times u sub 2, right? And then we're going to have, what are we going to have? Plus, be minus 3/2 t plus 3 is plus 6, right? U sub 4. And so I think that'll work. Now this is, we want to think of this as f of t minus, let's not use f. How about h1 of t minus 2 times u sub 2 of t plus h2 of t minus 4 times u sub 4 of t. So I'm putting this in terms of the table, right? So then h1 t minus 2 is 3/2 t minus 3. So that means that h1 of t must be 3/2 times t plus 2 minus 3. And so that's going to be 3/2 t plus 3 minus 3. Oh, it's just 3/2 t. Very good. And then h2 of t minus 4, we want to be minus 3/2 t plus 6, right? And so therefore, what is h2 of t? Well, I'm replacing t by t plus 4 now, plus 6, and that is minus 3/2 t. Let's see, is that minus 6 plus 6? Very nice. Good. Okay, so now we see what our f of s is on this side. It's just going to be e to the minus 2s times 3/2 s, and then 1 over s squared, right? Minus 3 halves e to the minus 4s over s squared. Good. We're going to rewrite that in just a second, but let's go back to our differential equation now that we've gotten our f of s. In fact, let me just rewrite it over here. So now our differential equation, when I take the Laplace transform of both sides, I said that we were having 0 initial conditions, so that zeroes everything out except for my capital Y terms. And so now I'm just going to rewrite this. It looks like I'm going to go ahead and factor out that 3 over 2s squared maybe. Right? Then I'll have an e to the minus 2s minus e to the minus 4s. What do you think about that? I think that looks nice. Okay. So now we can factor out the s squared plus 3s plus 2 times y. And I'm just rewriting everything here. So let's just go ahead and divide that through. That'll just save a little bit of space here. 3s plus 2. Go ahead and get rid of that now. Okay, and then we have our e to the minus 2s minus e to the minus 4s. Now, remember what we were talking about before? Think of this as e to the minus 2s minus e to the minus 4s times h of s. And so what is the solution going to be at that point? Our y of t then is just going to be u sub 2 of t minus u sub 4 of t. Oops. I'm trying to hurry because I'm running out of time. H of t minus 2 minus u sub 4 of t times h of t minus 4. Okay, we're going to finish this one up in the next video, I think, because the inversion of this is going to take a few minutes. Okay, I'll meet you back here at the next video.